Okay, picking up where we left off on page 444, we're talking about how the standards committees work. There's actually several of them. IEEE is a good one. That's Institute for Electrical and Electronics Engineers. They may have lots and lots of standards. The Internet Engineering Task Force, the IETF, is the one that does an awful lot of the things like the TCP/IP standards and things of that nature. International Telecommunications Union does most of the telephone kind of things. So it's important to understand how this fits into the big picture. So there's a story here in the book talking about the 802.11n. You know, they had the B standard, the A standard, the N standard, then they have a bunch of others, right? So N was supposed to be really cool. So they started the process in 2005, and they sent out basically a proposal saying, okay, vendors, come back to us with some ideas on how we're going to increase the range and speed of our wireless network. Okay. So that was their idea. They start out with a request for proposals in 2004. In 2004 they did. Well, they got back 30-something of them, only 4 of which were complete. So they basically discarded that, and now they ended up with 4. They chewed on it a while and never could really get a consensus. And the way it works in this networking committee, it's not like voting and then whoever gets the highest votes. There has to be a fairly large win before a standard can get put in. So if you have 2 competing standards which are equally well, they're probably going to stay in committee for a really, really long time. So in 2005, they had no overwhelming majority. And then, so what happened is the company said, you know, let's say I'm Motorola and I'm proposing one standard, and you're 3Com and you're proposing some other standard. And they looked at each other and said, you know, at the rate this is going, you know, our customers are going to be old and gray before we have this product come out. Why don't we sit down together and merge our proposals so we end up with just one proposal? Because the standards committee is never going to, the standards committee on its own is never going to break the logjam. We're going to have to do it. So that's what they did. They had 3 remaining proposals. They merged them all together and ended up with one proposal. Now, if you only have one proposal, it goes a little bit faster through the standards committee. So they did that. They merged the proposals in 2006. And then later, in 2009, the standard was finally published. 5 years later. Wow. Okay. This is the way these things work is pretty bad. I mentioned to you guys that when we had a security problem with the wired equivalent privacy, the WEP standard, one of the things that happened is these people got together, the vendors got together and says, you know, we can't wait for the standards committee. You know, we're hurting now. We have people now who are not using our technology because there's a security flaw in it. We need an alternative. We need it now. Well, standards committees don't work that way. So they put together a Wi-Fi alliance, and they came up with, essentially is the Wi-Fi Protective Access, WPA. By the time it got through the committees, it changed its name to 802.11i, and then the Wi-Fi Alliance people basically said, well, we're going to certify that, and we're going to call it WPA2. Okay, so bottom line is that companies have really no choice but to just ignore the standards committee, produce their own thing, and then have the standards committee come back and ratify it, so to speak, after the fact. So a lot of companies were selling 802.11n products long before the standard actually came out. That's just the way it works. Okay. There's an interesting sidebar, one of those little shaded bars in the textbook, talking about standard essential patents. Okay, you know, patents are kind of weird. Let's say, for example, that I'm using, I have a particular standard for, I don't know, transmitting video, and it requires the standard itself requires the use of a particular compression algorithm, which has a patent. Well, I don't really have a choice, do I? If I'm going to use this standard, I have to use that technology, and therefore I have to pay. And so they came up with this phrase. It's called the reasonable, well, it's called the standard essential patent. What that means is this is a unique scenario where people don't have a choice. And so to prevent people from just charging any price they want because there's no competition, they came up with RAND, reasonable and non-discriminatory. These are good lawyer terms. Reasonable and non-discriminatory prices. Reasonable means it has to be small. Non-discriminatory means I can't charge this guy 5 cents and this guy 4 cents. So it's going to be 4 cents for everybody, and that's how it works. So it's kind of interesting because, most of the time patents are about maintaining intellectual property, that kind of stuff. This is not what this one's about. This one is making the intellectual property available to others. Kind of the opposite of what the Trademark and Patent Office is about. Okay, on page 446, they talk about legal issues. And this is just kind of a listing of unrelated issues. So one of the things is, the entire issue of packet networks, the whole thing and TCP/IP was basically funded by the Department of Defense. It was done with DARPA, the Defense Advanced Research Project Agency. From 1969 to about 1980, they ran the entire ARPANET, which was that later became the internet. So all of the basis for the internet was funded by the military. So they can't keep any secrets. If it's funded by the U.S. taxpayers, then it's available to everyone at no charge. So that's cool. The National Science Foundation kind of picked up about that same time and started making these things available to universities. So the ARPANET was really about defense contractors and defense installations. And then, when the universities got into doing weapons research and that kind of stuff, they extended the arm using the National Science Foundation. So once again, the National Science Foundation funded almost all of the universities' internets. So again, taxpayers paid for the internet. Okay, cool. And then the National Center for Supercomputing Applications at Champaign, Illinois, University of Illinois at Urbana-Champaign. These guys came up with the first graphical version of the browser. Now, the browsers up to this point had been just command line things, just like DOS prompt. But they came up with Mosaic, which is a graphical browser. They were the first, and again, they were funded through the national funding. And so once again, when Mosaic was released, they gave out the source code to people saying, here's what we did, because they couldn't charge for it. Cool? Okay. The Federal Communications Commission. These are the guys who make the airways available. This is really what most people call the unlicensed band. There's actually a frequency band in the radio range that was set aside for industrial, scientific, and medical, ISM. So sometimes you may see it as the ISM band. And what that meant was, this is a band of relatively low power transmitters that are connected, and so you don't have to come to us and ask for a license. You can just use them as long as you maintain the following. You do this, 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 and this. Now, this same organization sells access to these phone carriers. Sprint, AT&T, and Verizon, and T-Mobile bid on this 5 gigahertz range so they can do additional phone usage in a particular area. So again, taxpayers' money involved, and even in some cases, we're getting money from the organizations like Sprint. Sprint's paying the government. They're bidding on airspace. Cool. One of the things that's kind of interesting is, this happened a while ago, but it's somewhat relevant to understand, is back in the day, we had one telephone company. And no one really had an issue necessarily with the phone physically in your house and the wiring that went to your house. That really wasn't what they were having troubles with. What they were having troubles with was long distance service. There was an awful lot of money to be made in long distance calls, not the monthly bill you got. And so somebody said that's unfair trade practice and it's a monopoly. And so they took AT&T to court and forced AT&T to break up into what at that time was called baby bells, Bell Telephone. So it had baby bells. And so to break up the business so that they wouldn't have a monopoly, and then open it up so other companies like Sprint could come in and offer long distance service. So you could get your phone bill from AT&T for the wiring, and then you get a second bill from Sprint for your long distance. Okay, cool. So the Telecommunications Act of 1996 basically said, we're now breaking it up so that you are now authorized to transmit whatever the heck you want. In other words, there's no limit on, oh, this is TV, this is voice, this is data. Anybody who's now in that business can do all the rest of the pieces. So cable companies can now do phone companies can now do cable. Okay, cool. The last one they talk about is the U.S. Patent and Trademark Office. And this gets a little complex. The idea in the original view of this is you really can't patent an idea. You have to patent a product. If I come up with a great idea, oh, that's a great idea. Well, ideas aren't really patentable. But you can go in and build something using that idea. And if it's unique or somehow adds to the public good, or makes products better, whatever it is, it doesn't have to be something brand new. It could just be a derivation or a next logical step in the evolution of the toaster. Okay. Now the problem is those rules, when they were written, didn't really apply to software. And so there was an awful lot of companies that said, at the beginning, the only way we could, if we had like an encryption or compression algorithm, it's kind of like an idea, and we can't patent that. So what they would do is they would put the compression algorithm onto a chip. Okay, they would take the algorithm and put it onto a chip, and then because it was physical and they could touch it with their finger, this chip is patentable. And that's how they got around the rule. So then that algorithm got covered by a patent because it had a physical implementation. And then after that, they just kind of went nuts and said, oh hell, anybody can come in and get a patent on software. And this is bad. They really needed to hold it down, and they didn't. And so now we're kind of back to the way we were, where maybe software patents are not a good idea. So there's an awful lot about that that's a bit confusing, and it would take a heck of a lot longer than this to describe it all. So software patents are, in my opinion, not a good idea. Okay, we have reached the end of this chapter and the end of the book, and the next video you're going to see from me is on the review for the final. All right, see you then.